All right, we got some more quadratics. Okay, we have another way of solving. Okay, so we talked about solving by factoring. We've talked about how you can find your x-intercepts using the graph. So then that's another way of solving. You can solve by factoring, solve by graphing. Another way is called completing the square. All right, so a perfect square binomial is what we've already talked about when we talked about intercept form and vertex form. That's this x plus 3 squared. So it's a binomial squared. Right, so this, if I square this, right, take my binomial, right, and I actually want to make this a perfect square trinomial. I don't know why I called that a binomial. I'm going to take my binomial and make it a perfect square trinomial, right? Remember, do not distribute that 2. Don't do it. That is so wrong. This is the same as saying x plus 3 times x plus 3, right? And we can FOIL. So x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9. I can combine those middle terms. Now this is my perfect square trinomial, right? You know it's a perfect square trinomial, one, because I squared a binomial to get there, but also it's always going to have this pattern, right, where I took the x squareds up top, right, or the first ones, and that was my first term. Then I took the 3 that was inside and I doubled it. Then I took that 3 and I ended up squaring it. That pattern holds true every time we have a perfect square trinomial. So keep that in mind. The goal of completing the square is to take one that's not a perfect square trinomial and make it a perfect square trinomial. Now that sounds crazy, but remember, I can manipulate any equation as long as whatever I do to one side, I do to the other. All right, so my steps for completing the square. The first thing I'm going to do is get my x's on one side and my constant on the other. So I'm going to start by adding 7 to both sides. I'm going to move that 7 over. I'm going to leave a gap in there. Okay, the next thing I'm going to do is I'm going to add a constant so that I have this kind of pattern here, right, where my number times 2 is in the middle and my number squared is on the end, right? So what I'm going to do is add a box, because that box is what I'm going to add to make it into a perfect square trinomial. Whatever I do to one side, I have to do to the other. So to figure out what goes inside your box, we're going to take half of our b and square it. Okay, because remember, this number that I, had in my parentheses, it doubled to get b, and it squared to get c, or to get my constant. So that means if I'm given b, I can divide it by 2 to figure out what that number is. So I'm going to take half of b, so 4 divided by 2 is 2, and then square it. Don't forget to square it. So that means I'm going to put a 4 on both sides. And I haven't changed anything. I'm just manipulating it because I'm adding it to both sides. Okay. Now that I have this pattern where half of b squared is the c term, this is a perfect square trinomial, which means I can write it as parentheses squared. I have a binomial in there. And to figure out what goes inside here, we just take that half of b, right? Half of b is what we're working with for these. Okay, and then over here, I'm just going to add 7 plus 4 is 11. So now that's the steps for completing the square, right? That's how we complete the square. The rest of it is just a matter of solving, like we've already talked about some, right? So if I wanted to solve x plus 2 squared equals 11, right? The first thing I have to do is get rid of that 2. To get rid of the 2, we're going to square root both sides. So I have x plus 2 equals square root of 11. Now, when it comes down to quadratics, remember we talked about how you can have, your x-intercepts. When we graphed it, we usually have 2. You could have 1 or you could have none, right? Well, if I have 2 x-intercepts, you have to take into account your 2 solutions. So taking the square root of a number, right? Let's say the square root of 4. I'll put this over here. Okay, if I have the square root of 4, the square root of 4 is 2 and also negative 2, because both of those squared give me 4. So whenever I take the square root when I'm solving my quadratics, I'm going to use a plus or minus. All right, so I have to take into account the positive and the negative root. All right, and then to get x by itself, I'm going to subtract 2. Now, I didn't type this in because I want the exact answer. I don't want a decimal, and I can't take the square root of 11, so we're just going to leave it the way it is. Simplify it if you can, but 11's prime. Nothing goes into it except itself and 1. And then my answer, we usually put our number first. So I'm subtracting 2, so I'm going to put the negative 2 up front, plus or minus the square root of 11. So that would be my answer. All right, and it looks kind of weird. So let's do some examples. All right, so the first one here, first thing I'm going to do is get this 51 on the other side. So I've got x squared plus 14x equals 0 plus 51, which is just 51. Right? Then I'm going to put my box on both sides. To figure out what goes in the box, we take half of b squared. So half of 14 is 7, squared is 49. So I put 49 in the box. That lets me write this side as parentheses squared. And in the parentheses, I take half of b. 51 plus 49 is 100. And now I can solve. We solve by always taking the square root. So I get x plus 7 equals, now the square root of 100 is a nice pretty number. That's 10. But don't forget, it's plus or minus 10. Then I'm going to subtract my 7 over. So I get a negative 7 plus or minus 10. Now, I don't have a radical there. That means I can go ahead and find my exact answers, right? Before I had that square root of 11, couldn't break that down anymore, and you can't combine radicals and non-radicals. So that was it. That was my answer. But here, I got rid of all the radicals. So if I get rid of the radicals, I'm going to figure out what my answers are. So I'm going to come up here. So I have negative 7 plus or minus 10, which means I have negative 7 plus 10. And I have negative 7 minus 10. So negative 7 plus 10 is 3. Negative 7 minus 10 is negative 17. So those are my two answers for this quadratic. Okay, you're never going to have more than two. It's either going to be no solution, one solution, or two solutions. Okay, for the second one, same setup. I'm going to start by subtracting that 11. And 0 minus 11 is negative 11. Get my green one, put my box in there. Okay, the more of these you do, the quicker they get. Right, in my box, I'm going to take half of b squared. So negative 12 divided by 2 is negative 6. Squared is 36. Because I'm squaring it, this is always a positive. All right, I'm going to put that number on both sides. So now we can rewrite this one as parentheses squared. Half of negative 12 is negative 6. Sign stays the same. Okay, negative 11 plus 36 is a 25. So then we can square root. So we have x minus 6 equals plus or minus 5. And I can break those apart. Let me add my 6 over first. Add the 6, so we get 6 plus or minus 5. Now I can break those apart. And we'll come on this side again. So I have 6 plus 5, which is 11, and 6 minus 5, which is 1. So my answers to this one are 11 and 1. All right, let's do it again. Start here. Now this one's a little bit different, okay? I can't complete the square until I get 1x squared. It's got to be a plain Jane trinomial. So I can get rid of the 2 by dividing. And if I don't, as long as I do it to every single thing on both sides, I don't change anything. But you have to divide everything by 2. So then this one's going to give us x squared plus 6x plus 8 equals 0. Now it looks like what I can do completing the square with. All right, so I'm going to start by moving that 8 over. So I'm going to subtract it. 0 minus 8 is a negative 8. Then we're going to put my box in there. All right, half of b, half of 6 is 3, squared is 9. 9 on both sides. So now I can write this side in the square. So half of b is a positive 3. Negative 8 plus 9 is 1. Running out of room. Square root, so I get x plus 3 equals the square root of 1 is plus or minus 1. Subtract the 3 over, put that negative 3 first, so I get negative 3 plus or minus 1. All right, then I can break it apart. So negative 3 plus 1, negative 3 minus 1, so I get negative 2 and negative 4 as my two answers. Okay, keep on going. So we've got, I got a 1 out front, so I'm good there. So I'm going to subtract that 23 over. 0 minus 23 is a negative 23. Put a box. Okay, half of negative 12 is negative 6. Squared is 36. All right, 36 on both sides. So then I have x plus or minus something squared. In the parentheses, I take half of b, so that's x minus 6 squared. Negative 23 plus 36 is 13. Square root. So I get x minus 6 equals, now 13 is not a perfect square. That's like the one we looked at. I'm just going to leave that as plus or minus the square root of 13. Then I'm going to add 6 over. I'm going to put that 6 first. I can't break that one apart because I can't take the square root of 13 and get a nice rational number. So I'm going to leave that as my answer. Okay, over here, same idea. Start by moving that 38. 0 plus 38 is 38. Put a box in there. All right, in my box, I take half of 14, which is 7 squared is 49. All right, so I've got my parentheses squared over here. Half of b is 7. Okay, and then over here, we've got 38 plus 49, which is 87. All right, we're going to square root it. So I get x plus 7 equals. All right, now, figuring out stuff that goes into 87. I know that, because remember, we want to try to simplify as much as we can. I know that 3 goes into 87. Just side note, if you want to know if something's divisible by 3, you add the digits. 8 plus 7 is 15. 15 is divisible by 3, so that means 87 is divisible by 3. But when I break it down, nothing goes into 29, so I can't simplify the square root of 87. But you got to make sure you try. Right, subtract my 7, put that negative 7 first, and then I can't break it apart because I still have a radical. Last one of these, add the 59 over. 0 plus 59 is 59. And then put my box in. Right, half of 6 is 3, squared is 9. All right, so then over here, take my half of 6, which is a positive 3, and then 59 plus 9 is 68. Square root, so I have x plus 3 equals. So then we're going to try to break this one down. 68 is even, so 2 goes into it, so that's 2 and 34. 34 is even, so 2 and 17, 17 is prime. I do have 2 2's. So remember, everything you circle, take one out. Right, and then I have a 17 left over on the inside, and we got a plus or minus. Okay, then I'm going to subtract my 3. So I have a negative 3 plus or minus 2 root 17. If you have a radical, you stop there. If you don't, you go ahead and simplify and do a plus equation and a minus equation to get your 2 solutions.